So thanks, everyone, for coming today. How's everyone feeling? Yeah? All right. Well, we're really excited for today's talk. We're going to go ahead and we're going to demo a lot of the generative AI capabilities of the Lakehouse AI platform that we announced earlier today at the keynote. And we're going to do so by taking one of the most popular use cases right now, a Q&A bot, from a POC all the way through to production in the next 40 minutes. So before we jump in, just quickly, I'm Eric Peter, one of the product managers on the AI platform team. I lead our efforts around generative AI and large language models.
I'm Joseph Bradley. I'm a product specialist, kind of sitting at the juncture between product engineering and customer-facing technical field. But most of my time at Databricks since 2014, I was in core engineering, building out ML, graph, advanced analytics on Apache Spark and our platform.
Awesome. So what are we going to do today? We'll do a quick refresher of Lakehouse AI in case you missed the keynote. We'll go through the use case, the customer support bot that I mentioned. I'll talk through the technical architecture we're going to build. And then we'll spend the bulk of the time demoing product features. So just one thing, I know this is a 300-level session, so we are assuming basic familiarity with kind of LLM concepts and terminology.
Cool. So I'll mention just a little bit about Lakehouse AI. I know you heard about it in the keynote, but I guess for the sake of something very LLM AI specific, I want to mainly reemphasize it for the point of data centricity, where it's easy to, in 5 minutes, get a LangChain, OpenAI, or whatever prototype based on LLMs up and running. But when you actually start talking about serious use cases, most of the problems become data problems. And so I think as we go through the features, which Eric will do most of them since he's really leading those efforts, I guess I want to remind people to focus on, one, the fact that, of course, data collection preparation is a data problem which needs to be tied in to the Unity catalog, the core data platform, just to make that transition smooth, because a lot of ML problems are just data problems. Next, as we get into using existing models or building your own, tight integration with that data platform, and then also smooth lineage and governance become really critical. And then finally, in model serving and monitoring for those end applications, that again is just essentially producing a lot of maybe inference tables for model serving. Monitoring, of course, is really just a data problem and asset, and so having those integrated becomes critical. There are some capabilities which were highlighted during the keynote, and some of which Eric will really walk through in more detail today. Under data sets, vector search and feature serving are really exciting capabilities, not all of which are necessarily specific to LLMs, but a lot of which become critical as you start thinking about how to put those LLMs into production for the .Q&A demoed or whatever. Under models, understanding this key quick list of curated AI models from there's some 240,000, I think, right now listed on Hugging Face. And even more elsewhere. Understanding which ones are applicable and well-optimized for your specific tasks is kind of part of our key offering. AutoML for LLM training, as you get 1,000, 10,000 examples and really can go into improving upon either cost or performance of models, becomes critical. And then finally, MLFlow evaluation is an exciting part, essentially for having a more interactive way to evaluate these complex LLMs and iterate on them and their prompts. Under applications, MLFlow AI Gateway becomes important for managing access to these powerful AI assets, but governing them across the organization. Model serving becomes important, where LLMs are, large and therefore unwieldy, and having optimized model serving is very helpful. And finally, of course, Lakehouse monitoring, where LLMs are just another type of ML model which produce just other types of data assets. So having this integrated into Lakehouse. So,
awesome. Thanks, Joseph.
Yeah.
So before we dive into the demo, I see some of the team in the audience here. So just maybe a quick round of applause for the team who's built a lot of these features. They've been hard at work. So what we've heard from a lot of our customers is that they actually want to create conversational interfaces over both their company's knowledge and their business processes. It's a pretty popular use case. There's a lot of business impact to it. You can reduce cost by automating interactions. You can drive consistency and quality of those interactions. And it's just some examples we've heard from some of our customers. We have a retailer taking their employee policies and putting them behind a bot to help drive compliance among their employees. We have a travel company making a bot that helps their employees understand the status of the logistical operations to improve efficiency. And then we have a telco that's taking and trying to deflect calls from their customer support team by creating a bot. At Databricks, we've also created a bot on top of our knowledge base to help improve the accessibility of our documentation. So today, for those who saw Casey's keynote demo, we're actually going to deploy the same use case here, a bot that answers questions about Apache Spark. What we're going to use here, we're going to use a pattern called retrieval augmented generation, which enables you to feed your proprietary data to LLMs to provide natural language answers to users' questions. So how does this work? Let's go through the technical architecture. First, before you get started, what you need to do is you need to take your set of documents, in this case, the Spark docs. You need to split them into logical chunks. So section 1, section 2, this part of the page, so on and so forth. This is because of the LLM's context window. Often they can't fit the entire document in. You need to take those chunks, you need to run them through an embedding LLM, and you need to store them in a vector database. When you get a question from a user, something that we often call a chain orchestrator takes over and processes the steps to connect together the LLMs and the various pieces of tech. So first, what that chain orchestrator does is it embeds the question using that same embedding LLM. It passes that to the vector database to do a similarity search to return the most relevant documents or the documents that are most useful for answering that user's question. After that, you construct a prompt, typically of the form, hey, respond to this question based on this set of docs. This is where you can do a lot of prompt engineering to customize the bot. The orchestrator then passes that prompt to an instruction following large language model, which reads the content, reads the document chunks, and returns back an answer that's returned to the user. So that's the architecture. Like most of our customers, the first thing that they need to do is, well, I've got this great idea. I'm going to take the Spark documentation. I'm going to make a bot out of it. So they need to do a POC to assess if it's actually feasible. So luckily, with frameworks like LangChain, off-the-shelf models like OpenAI, it's really, really, really easy to go do a quick POC to see if it can work. LangChain and OpenAI, they happen to be deeply integrated with the Lakehouse AI platform, so we'll go ahead and we'll use those today. All right, so I've kind of preloaded here. What we've got here is I'm just going to walk through the process of kind of quickly creating this POC with LangChain. And then what I'll do after that is I'll take this bot that I built, and I'll step-by-step go through how we bring it into a scalable production-ready API.
Maybe zoom in once.
Yeah, actually, you know what I'm realizing? That I'm ready to go ahead and use OpenAI, but I have a problem before I even jump in. How am I going to get access to my organization's OpenAI credentials? And so not only do I need access to them, but I need to securely distribute them to the rest of my organization, and I need to make sure that there's no cost runways. I know where the cost management and the governance of these credentials. And so MLFlow AI Gateway that we announced earlier today, solution to this exact problem. So what is MLFlow AI Gateway? It enables you to manage, govern, evaluate, and switch between different generative AI models. Importantly for the folks out here, it works with any LLM, open source or proprietary, and it puts a common abstraction over those models, making it easy to switch later and keeping the people who pay the bills happy and as well as the security folks happy, knowing that there won't be credentials sitting around all of your notebooks. So let's actually see this in action. So first, what I'm going to do here, as I mentioned, we're going to use OpenAI as the instruction following LLM. And so you can see here, I can connect to the gateway. It's actually pretty easy. Import the gateway. We've built a LangChain integration for the gateway as well. So works just like any LLM inside LangChain. Oh, zoom in. How's that? Then next, what we're going to do, so we've got OpenAI connected here. I'm going to go ahead. We need an embedding LLM. So which embedding LLM do I want to use? As we announced earlier today, our model guidance. So we actually have a team of people. Their job is to monitor open source models, check out what is state of the art, test them for a variety of different factors, quality, cost, so on and so forth, and then put what we believe to be the best of breed models up here on this page for y'all to use. We actually take it one step further. Not only do we curate these models, we preload them into the Databricks platform, and then we optimize the end-to-end experience all the way up through making serving orders of magnitude faster for these models. So this will save you time. It'll let you get started quickly, and it'll save you money in the long run. So we'll go ahead today. We'll use E5 Large v2 as our text embedding model. I've preloaded it in a model serving instance, and it's sitting in the gateway right now. I'll talk about the details of model serving later. But what we need to do now, so we've got these two models. We've got the embedding LLM. We've got the instruction following LLM loaded. And now I need to execute this top part, chunking and embedding the Spark documentation. So before this, I actually found the Spark docs sitting in a UC volume, which is our solution for managing non-tabular, unstructured data with Unity Catalog governance. And so you can see here, let's see, we've got the docs kind of loaded here in this UC volume. And then I'm going to come down here. And we're just going to go ahead and use LangChain, again, to do this quick POC. So I'm using their directory loader. Great part about UC volumes, it's just like accessing a regular file. So this takes about 20 minutes to run, so I've got it cached. Next, we'll chunk those documents, again, using LangChain here. And we end up with about 3,000 chunks of 250 or so documents. I need to put these into a vector database. So again, I'll just use Chroma. I've preloaded this since it takes a little bit of time to run. But you can see here that I'm just connecting to the gateway, just like I would any other LLM inside LangChain. So super easy. Now let's do the rest. So for anyone who's used LangChain before, pretty straightforward to get started. We'll load the QA chain. We'll connect it into the OpenAI, and we'll go ahead and run it. And we will see, if you remember Spark Connect, OpenAI does not know about this off the shelf, and it was able to answer this question with a few retrieved documents. So POC, obviously, in the background, Joseph and I tested this a little bit more than on just one question, but we got to the point where we felt comfortable with it, and we're ready to move forward. So before we do that, just to put the architecture on screen, again, we have LangChain doing the ETL. We have AI Gateway sitting in front of the models. And we have LangChain acting as our chain orchestrator. Awesome. So how to productionize it? I'm guessing we have a lot of data scientists and MLEs in here. So for anyone who's tried to build a POC, seen it working great on their laptop, you know that this is the hard part of the journey. How do you actually get that notebook to run as a scalable, production-ready service? So like I promised, we're going to walk through challenge by challenge. I've got 25 minutes to do this, so keep that in mind. First, I need to have a scalable, production-ready vector index. I need this thing, a couple business requirements that we have for this. One, I need to use embeddings that understand the nuances of Spark lingo. I want to make sure that I'm getting the exactly right documents returned back from that vector index. 2, I need the vector database to continually reflect changes that are made in the documentation. If a user adds in, or one of our developers adds a new feature, users are definitely going to have questions about that. And 3rd, we expect to get hundreds of QPS. So I need a vector database that can scale up. So what I'm going to do here, first, let's go through the first requirement, getting embeddings that understand the nuances of Spark lingo. For that, I'm going to use AutoML. And so we announced earlier today AutoML for embeddings. So I'm going to go ahead. I'll just come over here to the Experiments tab, create an AutoML embeddings experiment. I'll browse for the training data set. So I think it's here. The clean Spark docs. I'm going to choose the model that I want to fine-tune. In this case, I'll just go with E5 large V2. Choose the document. And at this point, I just need to sit back and wait. I've preloaded this model in a serving endpoint. So let's go ahead here. I have the AutoML model preloaded here, so you guys don't have to wait while AutoML trains that model. Like I mentioned, it's optimized for fast inference because it's in our curated collection of models. So we've got that. Let's go back. How am I going to tackle the next 2 challenges? The vector database. How is it going to continually reflect changes? And how am I going to handle hundreds of QPS? So as we announced earlier today, our vector search product. Now, vector search is an incredibly simple product to use, yet it gives you full control and customizability. So how does vector search work? It's really easy. You take a delta table, you choose any embedding model from your MLFlow or Unity Catalog model registry, and you pass those in to vector search. And out the other side, you get a scalable, production-ready vector search API. For anyone who's built a vector database before, spent hours building synchronization pipelines, this is much, much, much easier. And we've heard from our users that this will save them hours, if not days of time. So let me just talk through a few key things here. First, it's serverless. So you don't have to worry about the servers. We worry about the servers. We worry about scaling it. 2, it auto-syncs with that source delta table. So if you delete a row, you add a row, you update a row, the vector index is updated. Every column in that delta table, it's exposed as a filter. 3rd, Unity Catalog governance and lineage is fully integrated. We've heard from some customers, we're going to put almost every single document that we have into a vector index over the next few years. That's not possible to do without governance. And finally, it's fully integrated with the rest of Lakehouse AI. So you don't have to worry about embedding generation. We use model serving with that model that you selected to both index your documents and generate embeddings at query time. So let's go see it in action. So what I've done here, it looks like I'll just hit refresh. So what we're going to go ahead and do is first, what I'm going to do is I'm going to use Delta Live Tables, which is our declarative framework for building scalable production-ready pipelines. I'm going to use Delta Tables to take the documents from the UC volume and run them through my preprocessing and chunking logic. So in interest of time, I'll just quickly go through this code. You can see we're feeding from this volume. We're reading the markdown files. I'll highlight just a little bit of the logic here. You can see I'm splitting these chunks into about 1,000. And I've pre-run this pipeline, so let's come over and look at it. You can see got about the 245 number, if anyone remembers from earlier, up to about 3.5K different chunks. So those are sitting there. I'm going to come back, and let's go ahead. Let's look at this data. So these chunks here You can see the IDs that I created for them, the original content. Each chunk's about 1,000 characters or so. So this is great because you now can just look at this delta table to see what's going to be inside your vector index. You can use SQL, you can use Spark, full debuggability, really, really easy to use here. So turn this into an actual index. So I think probably folks saw this code already in the keynote, but we connect to the index here. And then we go ahead, and like I said before, to create the index, you point it at the delta table. Tell us what the name of the index you want is, just so you can reference it later. And you point it to which column to embed, and that model that I think I showed you guys a few minutes ago earlier. So I've actually pre-created this index. So I'll come down here, I'll grab it, and go ahead and let it run here. And we can see the chunks that are returned. So Spark Connect overview, some more documentation about Spark Connect, so on and so forth. So at this point, we have a production-ready pipeline and a production-ready vector database. All that's left, I need to integrate it into LangChain. So I'll do that. You can see I've connected back to LangChain. By the way, I just copied the POC code, and I'm working through it over here. So I've got this code here. I'm connecting back to the gateway. You'll notice I'm not connecting to the embedding model. This is being handled completely by the vector search product under the hood. I'm going to connect to the index like you saw, load my QA chain. And then what you'll see here, because of the fact that vector search also has a LangChain SDK, it's super simple. I'm just replacing this original line with this new line, and it's integrated. The thing that you'll notice here is while this is the same syntax, in this first line, the embedding of that query is actually happening in the notebook. In this second line, it's happening in model serving in a scalable way. So I'll just quickly run this.
You want to zoom in?
Oh, sorry. Thank you. I can see everything. You guys can't? So we'll go ahead and run this. And what is Spark Connect? You can see the answer along with the different retrieved documents. So at this point, remember, let's go through the architecture. So this was what the POC was that we built. Look up at the top right corner. I've now replaced it with a scalable production-ready architecture. And I've actually simplified my life. You'll notice that before, I was embedding this question, and I was passing that embedding into the index. Now, I'm just running a similarity search for that question. Significantly easier. All right, so moving on, let's talk a little bit about iterating on and evaluating the bot. And so for anyone who's built a POC, you know that you're inevitably going to have to make changes. You're going to get new requirements from business stakeholders. And in this case, our business stakeholders told us a couple things. One, they want code samples to be returned in as many questions as possible. And two, if someone asks a question that's off topic or offensive, they want the bot to kind of politely say, no thanks, I can't answer that. And so we'll do this with prompt engineering. Who in the audience has prompt engineered before? Yeah. So if you've done prompt engineering, you know it's a highly iterative process. You're going to try lots and lots of different prompts. I think Joseph and I sat around for several hours trying to figure out what the right prompt is. So there's a couple challenges. One, how am I going to keep track of all of those prompts? And then two, how am I going to compare the outputs? Luckily, we have MLFlow evaluation that we announced earlier today as well. So let's see it in action. All right, I'll remember to zoom in this time. And so again, we're connecting back to the gateway, connecting to the vector search. What I've done here is I've pulled out just the default LangChain prompt. So pretty basic, pretty simple. Use the following pieces of content to answer. And then what I've done down here, you can see it working. So let's go ahead and run it. And while it's running, we can look at the second one here. And so what You can see the answer here. So it works. Now, this next prompt, what we've done is we've said, try to provide a code sample. If you don't know the answer, say I don't know. If it's unrelated, say I can't answer questions. We're just going to show one prompt here, but we went through many, many different iterations. I think at least 15 or 20 to get this working. And so what we're going to do, in interest of time, I won't rerun it, but you can see that this prompt is actually spitting out a code sample in the middle. But I need to compare it against all of these other examples that the team gave us. And you'll see I've included a few in here, like what's a clothes hanger? Nothing to do with Apache Spark. And I've included the least offensive version of an offensive question that I could think of here. The bot should also not answer that. So how does this work? Super simple. We'll pass the questions to an array, to a data frame. And if anyone's used MLFlow before, you'll recognize these interfaces. Start, run. You're going to log the model so that we have a copy of it. We know exactly what model produced these answers. This will come up later, so remember that I logged this model. And then we'll call MLFlow.evaluate. This is what this will do. It'll actually kick off, and we'll do the same thing for both Model A and Model B. In interest of time, I'll just open up the experiment that I ran before. This takes a couple minutes to run. So come over here to the evaluation interface, and we'll go ahead and we'll take a look at.
Zoom as well here.
Yep, we'll zoom in as well here. Prompt A versus prompt B. So remember, prompt B is the engineered one. So how do you load a JSON? Remember the answers here. This one has code. This one doesn't. What is a clothes hanger? I can't answer questions on that topic. Unlike the first bot, which was, I think we all know what this text means, but I'm guessing a user has no idea what relevant context actually means. And then here, who do you love the most? Again, politely declines to answer that question. And then, we can see here there's code for exploding an array, whereas there's not code here. So at this point, I think we'll say prompt B, and we're going to go ahead and move forward. So evaluating your model, significantly easier with MLFlow. All right. So next up, serving large open source foundational models. Those pesky business stakeholders, what they said was, Eric, when you're building this bot, make sure you think about quality versus cost versus latency. Don't use a super expensive model if you don't have to. But this poses two challenges. One, what open source model am I actually going to try? And then two, how am I going to serve that large open source foundational model? So the first one we already talked about. We talked about our curated, best-in-class open source models. In this case, we'll just grab MPT7B. And then for the second challenge, we announced earlier today model serving, optimized for LLMs. So orders of magnitude faster than just naively loading the model into the GPU. So that's what this little purple lightning bolt means. So model serving, super easy to use. I will demonstrate how to create the endpoint a little bit later, but for now, we can just go ahead and take a look at our serving endpoints. And I've preloaded MPT7B. Keep in mind, this was super easy. Because we preload these models into your catalog, you have them available. It's a click of a button to turn up that endpoint. We can just quickly query. All right, so we've got the model. In the interest of time, I am not going to actually show you how I integrate MPT7B into the LangChain, but it's super easy to do. All you have to do, you come back over to your gateway, and you would replace it with a new route, and then you just swap that one line, one variable. Super, super easy. All right, model serving. Next up. Well, the LangChain works great in a notebook, but everyone here knows a notebook It's not a production-ready artifact. It's not how the world works as much as we'd like it to be. And so how are we going to turn this LangChain-based notebook into a scalable API? Super simple. Model serving, same answer as before, but this time we're going to use the CPU version of model serving. So all the same great benefits as GPU model serving, just slightly less expensive. And you can load any model into CPU serving. You can load a LangChain, another type of chain, Python code. You can load an XGBoost model, so on and so forth. Anything that you can put in MLFlow. So I'll actually this time, one thing, actually before I create the serving endpoint, you guys remember how I mentioned earlier, hey, I'm logging this into MLFlow? So now what I can do, because I have this model and I was happy with it, all I need to do here, just come over to serving. I'll create a new endpoint. Just call this live demo. I will go ahead and select that model. So OpenAI one, we'll confirm. We'll grab version 1. We'll put it on a CPU. I'm expecting a fair amount of requests, so I'll crank that up. You can scale to 0, so when it's not used, it goes back down to 0. And this checkbox, enabling inference table, I'll come back to it in just a minute. We can create that serving endpoint. I've actually pre-created them just in the interest of time. But if we come back over here, we can see I've got both the OpenAI version of the bot and the MPT7B version of the bot running. So solve that problem. Back to the architecture. So remember the original POC architecture? We had LangChain over here in a notebook. Now we have LangChain behind model serving. So scalable API. CPU model serving. All right. Next two challenges. First, Joseph and I, we think the bot's great. We hope you guys do too. But we need to go check with our business stakeholders. Do they actually agree that they like this bot? Is it giving the right answers? For anyone who's worked with, built a POC, needed to show it off to business stakeholders, it can be a challenging experience. You need to figure out a way to expose to them some type of web app that they can see the model in. No business stakeholder wants to be handed an API. Two, you need to get feedback from them. I don't know how many of you have had really frustrating conversations after one of your users tested the thing. They call you up the next day. They say, yeah, it's working great for some things. A few of them aren't that awesome. I kind of forget which ones, though. But you need to know exactly what feedback you get so you can improve the bot. So how do you get that feedback directly on each one? And then how do you know exactly what the bot was saying, what was said to the bot, and what it returned? So this challenge, getting feedback from stakeholders, it's actually very similar to a challenge that you face once the bot's in production, which is continually monitoring it, seeing what's working, what's not working. And so what we're going to do here, we're going to use our Lakehouse monitoring tool to help with this. So Lakehouse monitoring, it's our integrated solution for data and AI monitoring together. And so what I'm going to do here is, if you remember, I just created a scalable API with both versions of the LangChain bot. And so what I'm going to do is I'm going to come back over here. I've built a Gradio app that I'm going to hand out to some of my business stakeholders. I won't go through this code because it's just boring Gradio code, but it's running from inside a notebook and exposed as a website here. It's a great way to kind of quickly be able to prototype, stand up a web app. And in this bot, in this page, I have the thumbs up and thumbs down. We'll wait for it to return an answer. But you can see here, so we have it working. In interest of time, we're not going to go through a bunch of questions right now, but let me just show you the architecture. So essentially what we have the Gradio app running in a notebook. It's hitting model serving endpoint 1 or model serving endpoint 2. I don't know if you saw this little checkbox here, try model version B. And those are calling down to the OpenAI or to the MPT model through the gateway. So what's actually happening behind the scenes is remember I mentioned earlier that little inference tables check mark? So we've enabled logging on these endpoints. It's a key feature that ties together our model serving product and our Lakehouse monitoring product. So these model serving endpoints, everything that's coming in and everything that's going out, it's going into what we call an inference table, which is the delta table, sitting in your lakehouse. In the Gradio app, we're also logging the thumbs up and thumbs down. You can imagine how in production you'd have your web app team add that feedback signal in, all linked together with a unique ID. I'm being told I have 5 minutes remaining. Cool. So we've got this. And what we're going to do here, because it's all built into the Lakehouse with Lakehouse monitoring, we've actually built a beautiful dashboard to look at the quality of the bot. So we can see, what's the average thumbs up, thumbs down rate. It's a custom business metric. Average token count, average latency coming out from the AI Gateway's logs. And then, of course, the actual IDs. Was it a good? Was it bad? Which bot did it come from? And so at this point, we have a scalable, production-ready Spark question-answering bot.